All right, we're going to start 4.2 graphing quadratics in standard form. This lesson kind of piggybacks lesson 4.1, working with graph shifting. In the previous lesson, we went from standard form to graphing form by a method called completing the square, which we learned a week before or so. Um, so we're going to continue with that, yet we're going to learn a shortcut. All right, so stay tuned for that. Here again is just the difference between standard form then the vertex form, reiterating that the vertex form tells us a little bit more about the location of the parabola. Standard form just highlights the y-intercept. Okay, here's the shortcut that's really going to help you guys and save you a little bit of time and perhaps some mistakes if you're struggling with completing the square. In order to find the vertex in standard form, all you need to know is take the opposite of b over 2a. So there's your b term, divided by 2 times your a term. Whatever that answer is, you substitute back in for x here and here, and then you run your calculations, okay? And then the y term will be the y coordinate of your vertex, all right? Um, so let's take a peek at that. Just some x-intercept definitions, y-intercept, find the vertex using the vertex formula, find the axis of symmetry. That's how we're going to graph. Okay, so we're going to graph x-intercepts, y-intercepts, vertex, and axis of symmetry instead of using the graphing shortcuts, following the patterns of our parent graphs. All right, so we got a couple examples here. First thing I can do is set set x equals 0 and solve for y. So 0 squared minus 4 times 0 plus 3 to find the y-intercept, which is 3. We already knew that. Okay, I'm not going to show that work the next time. But every time I find an important point, I'm going to write it as a coordinate. Okay, so there's my y-intercept. Okay, to find the x-intercept, you set y equal to 0 and solve for x. So 0 equals x squared minus 4x plus 3. This one is factorable. What multiplies to be 3 and adds to negative 4? And that is negative 3 and negative 1. Therefore, zero product property tells me x equals 3 and x equals 1. These are x-intercepts, so I'm going to write them as coordinates. Lastly, I'm going to use my vertex formula, okay, which has to do with the opposite of b over 2a and then f of whatever that answer is. Okay, so I'm going to find the x-coordinate of my vertex, which also doubles as my axis of symmetry. So the opposite of b, so the opposite of negative 4 over 2 times our a value is 1. So that's 4 divided by 2, which is 2. Okay, so according to my vertex, that's the x-coordinate of my vertex. All right, but it's also my axis of symmetry, my vertical line of symmetry that cuts my parabola in half. Now to find the corresponding y value that goes here, all right, all I have to do is substitute my 2 back into my original equation for x. So y equals 2 squared minus 4 times 2 plus 3. Okay. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. Therefore, that comes up here. So if we plot all the important points, my vertex, my axis of symmetry, my x-intercepts, and my y-intercept, I should have a pretty accurate graph of my parabola. So 2, negative 1. My x-intercepts are 1 and 3. And my y-intercept is 0, 3. And I can use the idea of symmetry to get another point over here. Okay. And there's my parabola. Okay, using the important points to graph it instead of the graphing shortcuts. Okay, which way is better? I don't know. At least with this way, you're highlighting all of your important points here, your x-intercepts, your y-intercepts, your vertex, your axis of symmetry. Okay, and I didn't pick up a graphing calculator once. All right, we could confirm that on the graphing calculator. I'm not going to waste time right now to do that. We're going to move on to the next one. All right, let's do the same thing here to find the y-intercept. There it is. Okay, my y-intercept is my c value, so 0, -6. Okay, that's important. Don't want to lose that. To find the x-intercept, set y equal to 0 and solve for x. Check to see if this one's factorable. What multiplies to be -6 adds to give you -5. -6 and +1. Zero product property. We get x equals 6 and x equals -1. Therefore, my x-intercepts are as follows. Lastly, we do the vertex and axis of symmetry using the vertex formula. All right, so the opposite of b over 2a. So that's 5 over 2, which is 2.5. So 2.5 what? Plug your 2.5 back into your rule. Crunch the numbers. And we get -12.25. Axis of symmetry at x equals 2.5. So everything that's highlighted are the important things that I need to graph. So 6, 0, -1, 0, 0, -6, vertex of 2.5, -12.5, which is going to be down here approximately, and we can get another point from the 0, -6 on the other side, right there. All right. So there's our parabola according to that one. If you want, we can check this one out. So type into y equals, type in our original equation, x squared minus 5x minus 6. All right, we should be able to look at our table to see if we have those important points. 6, 0, I see. What is that? 5, -6 on our graph. Right there it is. 0, -6, -1, 0. Our vertex is going to be exactly between these 2 points. So it is going to be at 2.5. If we look at the graph, let's see if we can touch. It does tell us the minimum is up there in the corner, 2.5, -12.25. So again, we received confirmation there. All right, let's try this last one. Y equals -2x squared plus 6x minus 8. Again, our y-intercept should jump out at you. It's a c value. So 0, -8 is our y-intercept. All right, how are you going to find the x-intercept? To me, I see a factor of -2 in there. So I can pull that out, -2. And then we're left with x squared minus 3x plus 4. And then we try and factor that. It's not possible. We have nothing to multiply to 4 and add to -3. So what are your options? We can't just rely solely on the graph and the graphing calculator. We have a method of completing the square. So this 2 has no impact on my x-intercept. So I'm solely going to focus my attention on this. Okay? So if I complete the square there, set that term equal to 0, all right, and use the method of completing the square. Let's see what we come up with. So if we take our b value, negative 3 divided by 2, square it, we get 2.25. This becomes my perfect square. X minus b divided by 2, so that's 1.5, equals negative 1.75. And then we go to solve this, we hit a brick wall. All right, we get x minus 1.5 equals a non-real answer. Can't be done. I cannot take the square root of a negative. Okay, so there's no real solutions, which translates to no x-intercepts. All right, does that mean I can't find the vertex? I should still be able to find the vertex of a parabola. All right, so if I use my trick of finding the opposite of b over 2a using the vertex formula, so the opposite of b, it's negative 6 over 2 times a, we get negative 6 over negative 4, which is 1.5. So your vertex is going to be at 1.5 what? Okay, remember this is the x value, all right, and our axis of symmetry. So I substitute 1.5 back into my original. I come down here to the left. Y equals negative 2 times 1.5 squared plus 6 times 1.5 minus 8. And I get a y coordinate of, let's see here, let's type it in. So negative 2 times 1.5 squared plus 6 times 1.5 minus 8, we get negative 3.5. So that comes down here and becomes the y coordinate of my vertex. So these are the only points I can plot accurately. 1.5, negative 3.5, about right there. And 0, negative 8 is here, and we know because our parabola is opening down, because our a value is negative 2, okay, I can come over 1.5 from here and get another coordinate. All right, so if we go to our graphing calculator now, and we type in this rule for confirmation, negative 2x squared plus 6x minus 8. Okay, I look at my graph. Okay, I should be able to touch my maximum. There it is, 1.5, negative 3.5. My y-intercept is 0, negative 8. And I also have, well, let's get confirmation from our table. So we go to our table. Should be the point 3, negative 8. And there it is. Okay. So once again, just some observations. Here's our symmetry, so it's got to be between 1 and 2. So exactly in the middle is 1.5. All right. And then we see the symmetry here from our other points as we progress in our table. Again, just some observations. All right. But the point of this lesson today is really utilizing the use of that vertex formula. Some of us struggle with completing the square, especially when the a value is not 1. All right. If we use the vertex formula here, okay, that could be a tremendous lifesaver and save you guys a lot of work and effort to avoid completing the square. Again, we're throwing a lot of techniques at you guys this chapter, and it's up to you guys to decide which one is useful at the time, which one is convenient. All right, so choose wisely and make sure you execute properly. All right, come back to class with any questions you might have, and we're going to continue on. Thanks, guys.